Cold recycling is fantastic in terms that it uses all of the materials that we already have in the pavement. Those are some of our best materials.
But we're not only going to be in the bound layers, which is the asphalt, we're actually going to get down into the aggregate and even into the subgrade soil. And this removes cracks and other forms of degradation to enhance the durability of the pavement.
We found that the roads that we were using recycled materials on, that we get a much longer life out of those pavements, which is a benefit to everybody, especially the taxpayers and the road users.
We're putting less greenhouse gas emissions in terms of material processing. We're obviously doing very little trucking as well because we're using the material on the road.
We can reduce greenhouse gas emissions. In some cases, we've seen 40, 50%.
We have 20 years of experience and other countries have 30 to 40 years, and these roads are working.
So with all the research that's been published and the great work that's been done on the cold recycling, it really is puzzling that it is not wider used across our country.
I'm David Jones, the Associate Director at the University of California Pavement Research Center, or as we call it, the UCPRC. What's considered one of the best pavement research centers in the country, perhaps the world. It also has a fully accredited laboratory by the American Association of State Highway and Transportation Officials.
My name is Travis Walbeck. I'm the training manager here at the National Center for Asphalt Technology, or NCAT. NCAT is a partnership between the National Asphalt Paving Association and Auburn University. We have the wonderful opportunity to do research, testing, and education that promotes safe, durable, and sustainable asphalt pavements.
My name is Ben Bowers. I'm an assistant professor at Auburn University in the Department of Civil and Environmental Engineering, and I do a lot of work with the National Center for Asphalt Technology, which is where a lot of my research takes place. And it is very involved with the cold recycling and full depth reclamation side of things.
The cold recycling process is, as it says, cold. We don't heat anything in that pavement when we're doing the recycling. Because we have many different ways of doing a cold recycling project, we can put something back together again for any design traffic that you want, using those existing materials and strengthening the underlying layers. So it's a very quick process, very limited impact to the road user. We can put traffic on it immediately, even before we put that new hot mix surface on the top.
Full depth reclamation is the process of recycling the existing pavement in place. But we're not only going to be in the bound layers, which is the asphalt, we're actually going to get down into the aggregate and even into the subgrade soil. We're going to pull all of that up, and this can go up to 12 to even 14 inches. CIR is cold in place recycling, and the difference between that and full depth reclamation is that it's typically only 3 to 6 inches thick, and it keeps in the bound layer. So we're only going to be working in the asphalt layer. CCPR is very similar to cold in place recycling. CCPR stands for Cold Central Plant Recycling. And the difference here is that we're going to use a separate piece of equipment. It's a mobile plant that we can bring in and actually put RAP from the road through this plant, stabilize it, and then haul it back out and use typical paving equipment to place that material back out.
One of the big problems around the country is our distresses are deeper in our pavement structure. And we're not addressing those stresses. We're just putting a coat of paint, if you will, on top of what is already in a bad situation. With these cold recycling techniques, with FDR, with CCPR, with CIR, we can go down and address those distresses that are deeper in the pavement. It appears to be more expensive up front, but we get a much longer life out of those pavements.
Cold recycled materials are a very unique material, and they have a unique set of properties that gives them the advantage. So something like hot mix asphalt, something like concrete pavement, those are bound materials. Everything is stuck together. Cold recycled materials are what we would call a non-continuously bound material. So that non-continuously bound nature of that material is very beneficial because it prevents cracks coming up from the underlying material. It has a lot of flexibility in it. It has a lot of give. It has a lot of resilience. It can deal with variability in the materials. It's waterproof, it's rut resistant, so it's very difficult for a crack to propagate through those materials. And that's one of the reasons why these materials work so well.
Now the beauty of this is not only do we use the existing roadway, but we can actually use stockpiled wrap that's located all around the country. We have millions and millions of tons of this material available. And the fact that we can use that material that's already been extracted from the quarry, we can use that material to rebuild roads and build new roads, completely rebuild our infrastructure using this material, putting that pavement back into pavement. And that's what cold central plant, cold in place recycling, and full depth reclamation can allow us to do. So the three key components of sustainability are economy, society, and environment. And these techniques are really cool because they hit on every single one of those.
We've developed a carbon accounting methodology that quantifies the emission reductions associated with these cold in place recycling projects. So these processes have significant emission reductions when we're looking at roads and aggregates that are already in place. In terms of quantifying the emission reductions, cold in place recycling achieves nearly a 50% reduction in carbon dioxide, and cold central plant recycling achieves right around 50% or so.
In-place recycling methods and recycling in general just makes good sense. From a cost and taxpayer perspective, we can reduce costs and we can have long life out of these materials.
We find it's a great investment for our taxpayers. And ultimately for us, the benefit of not having to haul and not having to dispose of that much asphalt at the landfill is a huge benefit for us. So it does provide good value to the taxpayers and a long-lasting street as well.
Since 2012, we've done over 400 lane miles of cold in-place recycling in the city of San Jose.
It cost roughly between $250,000 and $300,000 a lane mile to do FDR plus an asphalt overlay. That's the all-in price. Whereas what's referred to as reconstruction, which is really more of a thick overlay by the federal definition of these things, generally runs over $500,000 a lane mile.
25 years ago, Caltrans started looking at in-place recycling as a way to save money and speed construction on low-volume highways. Now we're using in-place recycling not only to speed construction and save money, but also to reduce greenhouse gas and improve sustainability as materials are becoming scarcer.
Getting funding is very imperative for the infrastructure of Mississippi. Typically on a lot of MDOT projects, we find what we call base failures. And the best candidates of FDR, you can feel it in the seat of your vehicle. It's detrimental if we don't begin using FDR on these roadways because the amount of money that we're using to dig up and replace the base and fill it up with asphalt is phenomenal.
For Caltrans, safety is the most important factor, and when we use recycling, not only we don't tap into virgin materials, but we have less lane closures, which translate into less potential for crashes and fatality.
I've been doing road construction for 52 years, and the one process I took away from DOT was full depth reclamation works. It's the greenest thing I can think of. You're doing everything in place. We get more or less a perpetual pavement out of a lot of FDR because we were able to go deep. And one thing we learned in South Carolina is the depth is more important than the strength. And when you get into 10 and 12 inch depth, you come up with perpetual type pavements.
Cold recycling has been around for over a decade in California and several decades throughout the world. It is still viewed as a new process or an unfamiliar process by a lot of engineers.
People want proof. Engineers want proof that certain engineering strategies they're using are going to actually perform in the field. These decisions that we're able to make to use these strategies are all based off of solid data that we've been collecting for decades.
And one of the reasons I think that other different DOTs particularly are hesitant to use cold recycling methods on interstates and high volume roads is because they don't feel it's time tested.
So we've been doing a lot of work here at NCAT, as well as with my partners around the country, looking at ways to ensure the durability of this material.
One of the most important things we do for these recycled materials is to understand the behavior. We sample materials from construction sites. We take cores from roads that have been built for 5 years, 10 years, 15 years, 20 years.
Here at the test track, we drive fully loaded trucks in circles 5 days a week and put 5 to 8 years worth of loading on that pavement in just 2 years.
The benefits of doing accelerated pavement testing is we can get answers about real traffic very quickly. Here at UCPRC, we can put down about 20 years of traffic in 3 to 6 months.
Through that, we're able to study the strains and the change and the deformation in the pavement and really understand when this pavement does degrade eventually, how quickly does it degrade, but also it tells us something about the longevity. And to everyone's surprise, one of these sections, the one with full depth reclamation, lasted 9 years, 30 million equivalent single axle loads, and we actually took it off the line because it was not changing at all. So we believe we built a perpetual pavement section, or a long life pavement, where we would only have to change the overlay periodically.
Our research testing, our knowledge, our modeling of pavements, our understanding of the behavior of the materials, we can confidently predict pavements that could last up to 80 years. We have the data to back it up.
What's interesting is we implemented that in Virginia on Interstate 64, just outside of Williamsburg, Virginia, and they not only replaced 2 existing lanes, but added 2 new lanes with this material, essentially mimicking the section that was built down here at the test track. And they saved roughly $10 to $15 million as the estimation that compared to traditional methods.
I think that cold recycling is not used more widely is because our decision makers who are managing the budgets in our agencies, they're trying to stretch their dollars as far as they can. In their position for 4 to 8 years maybe, are not there as long as the life of the road should be in the first place.
The traditional approach to maintenance and rehabilitation is just to keep milling off the top and putting a new thin layer on the top of it. The problem is with a lot of pavements, they are carrying far more traffic now than when they were designed.
When we just mill off the top couple of inches and replace them, if you overlay cracks or fatigued pavement or stripped out pavement due to moisture, it's just going to come back. Cold in-place recycling pulverizes the material in place, removes those cracks, restabilizes it, and you put that new surface on, it's going to last much, much longer.
I was at the beginning of when Caltrans first started looking at in-place recycling. I saw that it was fast and it was cost effective. We have now built over 100 of these strategies in California. These strategies are still performing after a couple of decades. It's a strategy that every city and county and state should be employing in their toolbox as ways to preserve and maintain our highways.
When people say, well, I think there are limitations to it, it's only for rural roads, I'm like, oh no, it's on the interstate. Places like Virginia, where you have cold central plant recycling right on top of full depth reclamation, I-81, I-64, and it's performing well.
Funding is obviously an issue for all the Department of Transportation. The only thing is we have to justify that adding a little bit more efforts in terms of time and money at the beginning would give us a much better product at the end, and we can get a long service life, and that would save a lot of taxpayers' money at the end.
In my opinion, FDR is the roadway to establishing a foundation for our roadways, the economics, and the money that the state of Mississippi is going to save. I think it's a great thing for the state.
cold in place recycling, full depth reclamation, and cold central plant recycling are all things that people should be paying attention to. You've got a single unit that's working in a small train that's getting it done, and you're releasing traffic on the same day. So minimal interruption, maximizing what's already been used. I think that's a win-win.
I definitely see the opportunity to expand the usage in the future because it makes sense. It makes sense from an environmental perspective, from a constructability perspective, and that's why I'm so excited about this technology.
In my opinion, recycling is not a choice in the future, it's a mandate.
I like good roads. I'm a human in this country. I want good quality roads just like everybody. It's imperative to our economy, to our social structure, to getting to the beach with my kids. I mean, all of these things are important.
We are going to make a commitment to the sustainability, to reusing our resources, and this is one of the great ways we can do it, using more cold recycling.
I firmly believe that cold recycling is the future of pavements. We have to use what we have in place. We have to do it more cost efficiently, we have to do it quicker, and we have to do it more sustainably. And cold recycling fits all the boxes for doing that, and we can get a really good pavement at the end of the day.